The point of this show me is to show you how to figure out the units for the rate constant. So I'm just starting out with a basic rate law where rate is equal to k times the concentration of A raised to the first power. This happens to be a unimolecular reaction where there's only one reactant. One of the annoying things about K is the units actually change from problem to problem because of the various rate orders for all these different chemical reactions. Solving for K is not really that difficult, and solving for the rate constant, the units for the rate constant, is not really that difficult. It's just simple algebra. For example, if the rate was measured in molarity per second, and the concentration was measured in molarity, and that's going to be raised to the first power, then just rearranging this equation and solving for K should tell you the units for K. Now notice, I'm not plugging in any numbers for the rate or any numbers for the concentration. I'm just using the units. So essentially, you're going to divide this side by molarity to the first power, which is molarity, and you're going to divide this side by molarity. So that means K would be equal to 1 over seconds. Now here we have another rate law where rate is equal to K times the concentration of A raised to the second power. And I'm going to do the same thing. If the rate is measured in molarity per second, and I'm trying to find out the units for K, then I'm just going to solve algebraically for K. Now the unusual thing about this one is this is going to be molarity raised to the second power, raised to the zero power. Anything raised to the zero power is 1. So that means that K should be equal to molarity per seconds. So for a zero order reaction, the units for K should be molarity per second. Now this one's slightly more complicated because you have two reactants, A, which is raised to the first power, and B, which is raised to the first power, which means the rate orders are both 1 and 1, or the overall order is a 2. So again, if the rate is molarity per second, and we're going to try to find out the units for K, that would be equal to molarity raised to the first power multiplied by, again, molarity raised to the first power. So therefore we have molarity seconds is equal to K times molarity squared. Dividing both sides by molarity squared, you can eventually come up with a rate constant where K, or units for the rate constant, where K is equal to, I'm going to change that to squared, is equal to 1 over molarity dash seconds, or 1 over molarity seconds. As you have probably noticed, as the rate orders get larger and larger, the units for K get more and more complicated. In this case, I actually have a third order reaction where A is raised to the second order and B is raised to the first order. So that means we're going to have molarity squared times molarity to the first power, which means we're going to have units of molarity cubed on the right side of this algebraic expression. So solving for K, you can divide both sides by m cubed, which means the units for K for this third order reaction would be 1 over molarity squared times seconds.